Hello. Today we're going to talk about parallel plates first. So parallel plates give you a constant E, constant electric field. So we're going to start from there. So if you have two parallel plates, say that's positive and this is negative. So this is connected battery. It's a positive and negative terminal. So this is called the battery, and that's positive and negative. So this side is higher potential, high electric potential. And this side is lower, right? So lower V and higher V. Let's say if we start with a charge and it's plus, okay, it's Q. And so in this case, the FE will be going to the right according to the plus and minus. The electric force will be going to the right. So if we just let go, then once you get here, the kinetic energy would increase, right? So kinetic energy, so I'm going to call this side B and that side A there, right? So kinetic B is going to be larger than kinetic A, okay? So according to the energy conservation, or mechanical energy conservation, right? So here, since kinetic energy increase, so that means your potential energy at B must be less than potential energy at A. Okay, so this together says that PEA plus KEA is equal to PEB plus KEB. Okay, so we know the potential energy when it comes from here to here for this positive charge, the potential energy has reduced. Okay. All right. So now I'm going to clear that. And now we're going to recall from chapter 6 that the work done by external force is always equal to the delta PE. And the work done by the conservative force is always equal to negative PE. Okay, so this is from chapter 6. So if we have the plates, so positive and negative, and we have positive charge here, okay, so we know the electric force is going to be on this side because it's positive. So the work done by the conservative force, okay, I'm going to call this as A and B, right? So usually we say this is A to B, right? So work done from A to B. But it's also, they also like to use this as BA like that. Okay, so A to B is writing as WBA. So this work done from here to here is equal to, so this is conservative force, right? So it's equal to FE times this distance here. So I'm going to call this one here D. So times D. And this is the same direction. So that's positive. Okay. And FE is equal to, so we're going to call this electric field is E. So it's E everywhere, the constant electric field. It's going to be E, and this, the charge is going to be Q. It's going to be EQ times D, and that's larger than 0. Okay? So the work done by electric force is larger than 0, and that's equal to the minus delta PE. So that's equal to PE final minus PE initial, and then there's a negative sign there. So that's equal to PEA minus PEB, right? So you can see PEA is larger than PEB, like we talked about before. So here is high potential energy, high electric potential energy for the positive charge. And then when it comes to this side, the potential energy drop. Okay, right. So I'm going to clear that. And now I'm going to recall for you for the gravitational in chapter 6, right? The work done by the conservative force. It's the work done by the mg, okay? So I want to give you an example. So this is the mg. And when you move this book from here to here, right? So then your mg will be doing negative work. So this is h, right? The work done by the conservative here, so this is the ground, right? It's equal to the mg, which is conservative force, times the h, and then times -1, right? Because mg is going down, h is going up, okay? And that should be equal to delta PE. And delta PE, you can see it's equal to mg h, and which is larger than 0, right? Right, so you go from here to here, and it should be a negative, right? Negative, sorry. So negative, and another negative, right? So it's become positive, right? So this is minus delta P, so this should be minus, sorry, right? So this is equal to delta P is the position here, right? The position potential energy here, which is mgh, and the bottom is 0, so minus 0, right? So it's equal to minus mgh, right? Okay, so that's less than 0, right? And you can see the work done is equal to the minus delta PE, right? And there's a negative sign there. So I just want to show you that one there. So work done by the conservative force is equal to minus delta PE. So that can be, that is also true in an electrical field situation. Okay, we're going to stop there. Until next time, bye-bye.